Hello everyone and welcome to my blog. My name is Simranpreet Kaur, and in this short video I'll be talking about how we can teach programming more effectively using insights from cognitive science. The article I'll be discussing is titled Retrieval Practices Enhance Computational and Scientific Thinking Skills, published in Frontiers in Psychology. The article explores how retrieval-based learning, where learners actively recall previously learned material, can significantly improve understanding of programming and computational thinking. It draws on the well-established retrieval effect in cognitive science, which shows that retrieval information from memory strengthens learning and enhances long-term retention. One particular compelling example in the study involved adult learners engaged in a series of logic-based programming exercise. After initial instructions, participants were asked not to, simply review content or repeat tutorial. Instead, they completed structured coding tasks that required them to recall and apply concepts like logical operators, conditionals, and iterations without reference materials. These tasks were embedded throughout the learning timeline and repeated in spaced intervals. The study found that this retrieval-focused approach deepened participants' comprehension and improved their ability to transfer knowledge to novel problem-solving situations. Let me bring this theory into practical teaching context. Say a programming fundamental course. Imagine we are in a week where students are learning about control flow statements in C++, such as if, else, and switch. On day one, the students participating in the demo-based lecture, I walked through real-world analogies like traffic signals to explain decision-making in code. Instead of reviewing notes the next day, I would integrate a retrieval-based activity. And here's how it works. I create a digital flashcard set using Quizlet. Each card includes a scenario and students have to write or select the correct control flow structure. Then we play a choose your adventure game. Yeah, that's interesting. Students are given partial code that runs a vending machine or an elevator simulation. At certain checkpoints, they are prompted to recall and fill in the missing logic based on the real user input. Another way I have incorporated retrieval practice is through exit ticket quizzes. At the end of each class, I give students 5 questions mini quiz covering key concepts for the day without access to notes. For example, after a lesson on agile methodologies, I might ask, list the 4 core values of Agile Manifesto, or what is the difference between Scrum and Kanban. To make it interactive, I sometimes use platforms like Kahoot or Quiz to gamify the process. At the end of the week, we revisit the same flashcards and scenarios, but now jumbled and without clues. This spacing and retrieval combination makes their learning deeper and longer lasting without any stress from the formal tests. So now let's talk about why this article is a credible resource. The article is authored by Osman Yassar, Jose Melekel, Peter Veronesi, Lane Little, Michael Mays, and Ibrahim H. Yeter. Yeah, lots of authors. These authors bring together a wealth of experience in computational science, STEM education, and teacher training. It was published back in June 2022 in Frontiers in Psychology, a reputable peer-reviewed academic journal. The study uses a mixed method approach combining hands-on coding challenges, structured classroom interventions, and cognitive recall strategies. Their conclusions are well supported by empirical data and grounded in prior cognitive science research, especially the retrieval effect. This article is clearly aimed at educators, instructional designers, and researchers offering practical strategies for improving computational and scientific thinking through retrieval-based learning. So when I incorporate retrieval-based activities into my own programming instruction, I'm not just following a trend, I'm relying on solid research-backed methodology from highly qualified scholars. Thank you for now. I hope you like it. Thank you.